Welcome to this lesson on single bonds. Single bonds are one of the fundamental types of chemical bonds that hold atoms together in molecules. They represent the simplest form of covalent bonding, where two atoms share electrons to achieve stability. Understanding single bonds is essential as they form the foundation for learning about more complex bonding types like double and triple bonds. A single bond is a covalent bond formed when two atoms share exactly one pair of electrons between them. This means that each atom contributes one electron to form the shared pair. The shared electrons are attracted to the nuclei of both atoms, creating a stable connection. This type of bond is the most common form of covalent bonding in chemistry and appears in countless molecules around us. In chemical structures, we represent single bonds using a single line drawn between two atoms. For example, in a hydrogen molecule, two hydrogen atoms are connected by one line. This single line symbolizes the one pair of electrons being shared between the atoms. This notation makes it easy to visualize molecular structures and understand how atoms are connected in different compounds. Single bonds have two important characteristics. First, they have a bond order of 1, which simply means there is one shared electron pair holding the atoms together. Second, in chemical notation, we represent them by a single dash or line drawn between the atomic symbols. These characteristics help us identify and distinguish single bonds from double bonds, which have a bond order of 2, and triple bonds, which have a bond order of 3. Let us look at some common examples of molecules containing single bonds. Hydrogen gas, represented as H2, consists of two hydrogen atoms bonded by a single bond. Chlorine gas, written as Cl2, has two chlorine atoms sharing one electron pair. Hydrogen chloride, or HCl, is a molecule where a hydrogen atom and a chlorine atom are connected by a single bond. These molecules are found in nature and industrial applications. Single bonds have distinct physical properties compared to other covalent bonds. In terms of bond length, single bonds are the longest among covalent bonds. This means the distance between the two bonded atoms is greater in a single bond than in double or triple bonds. Regarding bond strength, single bonds are the weakest among covalent bonds. This is because they involve only one shared electron pair, whereas multiple bonds involve more shared electrons, making them stronger. One unique feature of single bonds is that they allow free rotation. Atoms connected by single bonds can rotate freely around the bond axis without breaking the bond itself. This rotation is possible because the electron density in a single bond is concentrated along the axis between the two atoms. This free rotation is important in determining the three-dimensional shapes and conformations of molecules, especially in organic chemistry. Let us summarize what we have learned about single bonds. First, single bonds involve one shared electron pair between two atoms. Second, they are the longest and weakest type of covalent bond. Third, single bonds allow free rotation around the bond axis, giving molecules flexibility. Finally, understanding single bonds provides the foundation for learning about more complex bonding patterns in chemistry. Mastering this concept will help you better understand molecular structures and chemical reactions.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.